Yeah, good morning all. So, like I said in the last class, today we will start discussing C# language. So, before we start discussing it, let me show you basic C# code. Okay. Sorry. I don't know why it is. Yeah. So, say we can say hello world. And some class name, and in this okay, there is one more, static void main, sorry, okay. Now let's run it. Okay, I should probably change to the directory. Yeah, so you see, I don't know if you're able to see. You're able to see, right, that it printed hello world. All right, so this program has a structure, like you have some using some statement using system, and then namespace. Inside that you are defining a class, inside that you are defining some main function, inside that you are giving some comments. Okay, so all of you did C programming, right, and all of you did object oriented programming course. So what is the difference between struct and class? In C you learned structs, right, and in object oriented programming you would have learned class. So what is the difference? Are they same or are they different? Yeah. Anyone? Or tell me what is a class? You did 2 courses, 2 basic concepts, and you have no idea of these basic concepts, which means you learn nothing in these courses. Why do we need classes? Or what is a struct? Many data structures are there, so what is special about struct?
We can create user-defined data types in the structs.
User-defined data types in a struct. Okay, fine. Sort of, yeah. Or, can anyone tell me what is the difference between an array and a struct? What is an array?
There is a question of single object, same object.
Right.
So there is a
Exactly. See, in any language, we have primitive data types. Like in C, we have primitive data types, right? Like int, char, float, double. All these are primitive data types, right? And then we also have derived data types. So examples of derived data types? Yeah, arrays and structs, right? Why? Because an array is made up of primitive data types. It is a sequence of, or it is a collection of same data type. You can have an array of integers, or you can have an array of characters, or you can have an array of floats, right? But all of them should be of same type. You can't have a mix of some integer, character, float, all those things, right? So an array is a homogeneous derived data type. Okay, whereas in a struct you can have a mix of different data types, different primitive data types. You can have some integers, some characters, some strings, you can have an array inside a struct, and so on. So you can mix different things. So suppose if I want to store the data of a student, now each student comes with different kinds of data: name, age, roll number, address, phone number, all these things. One is a number, age is an integer, name is a string, address is a string, maybe height, that can be a float, right? So we have different data types, but I can store all of them in one struct called student, right? So that I can treat each student as one unit. Otherwise, suppose if I don't have struct and I have only arrays, then how do I store this information, say of all students? I should have an array of ages of each student. I should have an array of addresses of each student. I should have an array of names of each student, an array of roll numbers of each student. So rather than storing student as a unit, we are storing all ages as one unit, all names as one unit, all addresses as one unit. In this, in my mind, I need to map that, okay, first element in this array, in the name array, is of the same student whose first element in the age array, which is the first element in the roll number array. So the first element across these arrays belong to the same student. So I need to make that mapping in my mind. That is too much complicated, right? And if say some student leaves or some student joins, then I need to ensure that exactly at the same position, that element should be removed from all the arrays and some element should be added at that position in all the arrays. If I miss even one array, I'm gone. So some student's name will be mapped to some other student's name, roll number or address or something like that. So these are independent data types, but the dependency structure is only in my mind, not in the computer. Rather than that, if I can treat each student itself as one unit and store all the data of that student at that place, that will be more convenient to me, and also that is more easy to understand for a human. And if I can code in such a way, that is more natural way of coding. So here object itself is the unit, student. Student as an object is the basic unit. I can have now an array of all such students. So the first element is a struct with all the details. The second element is another struct with all the details. So first element is a student with all the details at one place. Second element is a student with all the details at one place. Okay, so struct as a unit, because you see in the reality around us, we deal with objects. Each object has some properties. Each object has some behavior. So if we can store all the properties and the behaviors of the object along with the object, rather than separating them into different arrays, that is more natural. That's a natural way of coding as well as a natural way of understanding the code, right? So that is object-oriented programming, where object is the key, object is the fundamental unit, right? So structs are heterogeneous derived data types, all right? So like the example I gave earlier, say I have many students where each student has name, age, roll number, and so on, right? So one way of breaking it up is horizontally like this. This is one way of grouping. So you have an array of all names, then you have an array of all ages, and then you have an array of all roll numbers. All right, these are different arrays. So you are sort of splitting the data horizontally. Okay, that is an unnatural way of doing it because these are not independent arrays. The names array is related to the ages array, is related to the addresses array or roll numbers array because the elements at the corresponding positions in each array belong to the same object. Okay, so rather than splitting like this, if we are able to split like this, that is better for us, right? So this is an object, this is an object, this is an object, this is an object. So we store one object at a time together, and if you want, you can have an array of all these structs, right? So now I have an array of structs where the first element is a student 1, second element is student 2, third element is student 3, and so on. Okay, so that is a better way of storing. All right, so okay, so that is struct. Now what is a class? Struct is heterogeneous data types. It's a heterogeneous derived data type where you can have a collection of different kinds of primitive data types. But what is a class? You used some I mean, what object-oriented programming did you learn language in the course? Java, right? So can you tell an example of a class and a method?
Class is like a blueprint of an object.
Okay, class is like a blueprint of an object. Fine. So what is an object then? Sorry? What is the difference between class and object?
So, if animal is a class,
Hmm.
squirrel is an object.
Hmm. Okay. Okay. So object is an instance of a class. Like in this case, struct. Every student has the same structure, right? Name, age, roll number. Say these three attributes we take. Now that is the template of any student. But if I have to store the details of this particular student, that particular student, some other student, student S1, S2, S3 and so on. So S1's name will be different, S2's name will be different, all these things. So S1, S2, S3 and so on, these are instances of the type student. So you can imagine student as a class and S1, S2, S3 as objects. Okay, so class is like a, even in normal parlance, we have classes and their instances. Like I can speak of a class called table, but you can't touch that class, you can't place things on that class. You can only deal with physical table, right? So all the different tables that you see, they are all instances of that class, the idea called table. So class you can think of as an idea, but the physical instances belong to that class. Okay, it is only with the physical instances that you can deal with, you can interact with. You can't do anything with the idea itself. Okay, but to discuss, I mean, to sort of group all these physical instances, you need an idea. Suppose if I ask you, bring a table. Now, if you don't know what a table is, just imagine in this universe there are no classes. Every object is different. Like this row, this table is different from that table. So each table is given a name, table 1, table 2, table 3, and so on. So you have millions of tables and millions of people, whatever it is. Now you don't have a concept of class. Every object is different. Just imagine how many objects names you should remember and how many objects you should deal with in reality, because every object is different. It's like a table is different from person, this table is different from that table, so they don't have any commonality at all. They're completely different. They have different names, so you need to refer to each one by its ID, by its unique name. Then how many should you remember? You don't have a way of grouping things in this world. And when you don't have a way of grouping things in this world, there are millions of objects in this world. Not even millions, there are billions of objects. Every object you should refer to by its name. Every object you should understand differently. Then this world will be chaotic, right? The only reason why this world seems sort of organized is because of classes, is because of, or another word is universals. We have universals and we have particulars. So table is a universal, this table, that table, that table is a particular. That is the reason why, even though we don't give a separate name to each individual table, we can deal with them, because we treat them as belonging to the class of tables. Otherwise, you will again ask me, what is a table? Because you will say, I don't have a concept of table. Table 1, table 2, table 3, this is a name, this is a name, this is a name. Each is an entirely different object. So you just tell me what object to bring. But I don't know that particular object, because in my room, I have different kind of table. In your room, you have different kind of table. I just want you to bring that object. I don't know the name in your room, right? So the point is, names themselves are possible because we have classes. Language itself is possible because we have classes. Communication itself is possible because we have classes. If classes are not there, you can't have names. You can't have common names. And if common names are not there, you can't communicate with anyone what you are discussing. In fact, in philosophy, it is said that you cannot communicate, say, the color of an object to anyone. Like if I say, this is yellow, then what is the guarantee that you understand that I am referring to the color? Suppose you don't know the word yellow. When I say this is yellow, how do you know that I am referring to the color of the object? I may refer to, because the statements all look similar. I can say this is table, I can say this is yellow, I can say this is broad, I can say this is wooden. All these statements are identical. Suppose you don't know any of these words, then how do you know what refers to the color, what refers to the name of the object, what refers to the type of the material of the object, what refers to the size of the object? You don't know any. So how do I point out to you that I am referring to the color of the object? This is yellow, or this is red, or this is black, whatever it is. How do you know that I am referring to the color? You don't know any of these words. I am just pointing to something. How do you understand whether I am pointing to the object or its color or its material or its size or whatever it is? Because all these properties are together with the object. I can't extract this property and show you this is the property I am speaking of. So how do we communicate anything? Can you guess? See, it's a simple method. although I cannot extract this particular yellow from this particular object, I can show you numerous instances of different kinds of yellow objects and say this is yellow, this is yellow, this is yellow, this is yellow, so that you will abstract the color out of those objects. I can show you a yellow cloth, yellow book, yellow ball, yellow pen, yellow table, all these things, and I will say this is yellow, this is yellow, this is yellow. Since everything is different except the color, you will understand that, okay, so he is referring to the color of the object. This is how we extract the properties of any object. Similarly, I can say, if I want to teach you the concept of round, I can bring in different round things. I can bring a round ball, a round a ring, or a round bangle, or different kinds of things, and I can say this is round, this is round, this is round. Then you will understand, okay, all these are round. So the word round refers to this particular property, right? So we can't physically extract the properties of objects. They are always together. But we can mentally abstract the properties of objects. That ability we have. So this is actually pattern recognition. So in machine learning or whatever you're doing, it is basically pattern recognition. Humans are pattern recognition machines. That is what we do day in and day out. So you recognize the pattern to identify something as a table. You recognize the pattern to identify someone as a person. You recognize the pattern to identify something as a laptop or whatever it is. You see repeating patterns and you extract those patterns, and that is how you name an object. Okay? So that is the fundamental concept of even machine learning. How does a machine learn? It learns repeating patterns. It tries to extract the patterns. That is what it tries to do. So when you build a model, it is based on some pattern. So whenever you see this pattern, say classify it as this or that. So classify something as oranges or apples because you see a pattern. So that's all. And we fundamentally are pattern recognition machines. It comes naturally to us. That's how we recognize patterns in language. That's how we can say, okay, this is Hindi, this is Telugu, or this is something else. We just have this innate ability to recognize patterns. That's why language is an innate ability. We have innate grammar. That's what Chomsky's theory is. Chomsky's hierarchy, if you have heard of, Chomsky came up with this theory that humans have innate grammars. They have innate ability to recognize the grammars of different languages. Grammar is nothing but the pattern. What is the grammar of a language? What is the grammar of some movie? What is the grammar of some dance? Everything has a grammar, which means everything has a pattern. So the ability to extract these patterns, ability to extract this grammar and recognize it, that is our innate ability. Okay, so fine. So this is one thing. So in object-oriented programming, basically every object will have some data associated with it. Like we said, student, name, age, roll number, all these things. That is data associated with the object. Now, is this data or will this data be always static? Can this data change over time? Like your age will change over time? Your address may change, right? Some things may be static, your name, maybe your roll number, at least as long as you are in the institute. Those may be static. But some things will change. Now who will change that? Someone should change. Now, whatever this someone who changes this data should have access to this object. So, in languages like C, you have to write functions which sort of take a struct as input and change the data and return struct as output. Okay? But in that case, you cannot restrict sort of which functions should access the struct and which functions should not access the struct. If you pass that struct to that function will do the job. Okay? But suppose I want to restrict. Only some functions should be able to access the data of this object. Some other functions should not access the data of this object. Okay, and I want to define those functions within the object itself. Like in Python, you all are familiar with Python, right? You can sort of say the length of a string using some dot length kind of a method, right? So that dot length, it can be a string, it can be an array. So some s dot length will give you the length of that string. So what is this dot length? This is a function defined inside the object called string, and only this function is allowed to read the string and calculate its length. You can't use some other function to calculate the length of this string. Okay? So functions inside classes are called methods. Alright? And you can define which functions can access the objects of a class, whether only the internal functions should access the objects of this class, or even some external class functions can also access the objects of this class, and can they only read, or they can write also, or they can modify also. Okay? So that is the difference. In a struct, you can't define a function inside a struct, but in a class you can define a function as well. So a class, to put it bluntly, is a struct plus functions. Struct can have only data, it cannot have functions. Class can have both data as well as functions which can modify this data or access this data. Okay? So that is a fundamental difference. That's one of the main differences between a struct and a class. Okay? So class is struct plus functions. Alright? So a class basically has two things, that is data and functions. Alright? And this data is usually called attributes, and these functions inside a class are called methods. So what is the difference between a function and a method? A function, if belonging to a class, is called a method. If a function is outside a class, it's just a function, it's not a method. That is the difference. Okay? Alright. So here, if you see, we have a class and we have static void main. This main is similar to the main function in C. You write int main and you write your entire code inside that. So that int main is the entry point for a C program. No matter how many other functions you define, your program always first enters the main function, and if other functions are called inside the main function, then this program enters those functions. If they are not called inside the main function, this program will never enter the or enter inside those functions. Okay, so that is the difference. Main is like a special function which is the entry point for your program. So wherever main is written, it doesn't matter whether it's written at the beginning or in middle or at the end. Your code will first enter there only. Okay, and then through that it is connected to the rest of the program. Similarly here also, static void main, this main function is the entry program for a C# program, entry point for a C# program. Okay, and in this you have like this command called console.writeLine. So here, as you can see, console is a class and writeLine is a method inside that class. And this is basically like printf statement. You want to print something to the terminal, you write like this in C# console.writeLine. In this case, hello world. So it printed hello world to the screen. Okay, so everything is a class, and inside this class you will have data and methods. Okay, so that's the basic structure. So the basic structure in C# is, so you have multiple classes, like say you can have class 1, class 2 and so on. These multiple classes are okay. Yeah. All right. One more thing. In C, you use this statement in the beginning, right? Hash include. Do you remember what? stdio.h, right? So why do you write this? Includes. Huh. Right. So there are some predefined functions which you want to reuse. You don't want to define everything. Like you can include some math.h to use some math functions. You can include stdio.h standard input output functions like scanf, printf. You can include string.h to use some string functions, all those things. So basically it's a library. Each one is a library. So what is a library? It's a set of functions. It's a collection of functions. So different kinds of functions you group in one file. Math functions you group in math.h. Input output functions you group in stdio.h and so on. So rather than defining those functions and then using them, you use the built-in functions, inbuilt functions. Okay. Now similarly, in our case, function is not the fundamental unit. Class is a fundamental unit. Now, the way there are some inbuilt functions, there are also some inbuilt classes. So if we want to use those inbuilt classes, again we need to include some files. Like in C it is include stdio.h, in C# it is something else. Okay. So these files are not called libraries, they are called namespaces. Okay. Library means it's a collection of functions, whereas namespace means it is a collection of classes. All right. So we have namespace. Okay. Namespace is a collection of classes. All right. Now multiple namespaces, so ns1, ns2 and so on. Multiple namespaces, I mean related namespaces, a collection of such related namespaces is called an assembly. I don't know if you have heard of, assembly files in Windows like DLL. exe you would have heard. Okay. So assembly is a set of related namespaces, and DLLs are it is dynamically linked library. Basically DLL means dynamically linked library. So first let me explain exe. Exe you all know, it is like some executable file. It is like a.out in C programming. So when you compile a file, compile a code, it is converted to machine language. So that machine language code is usually default name is a.out. So when you run that a.out, your code will run. All right. Similarly in Windows, it is .exe. So when you run .exe file, your code will run. Okay. So .exe files are complete full-fledged codes. They have everything needed. All the libraries, everything linked and come together as exe files. Okay. But sometimes you just want to keep some library files independent and then link them whenever needed. Okay. Those are called DLLs. Even in C, I don't know if you were introduced to dynamic linking in C. Like while compiling, you can link some library files separately. Okay. So they are readily available for you to link them. Okay. So DLLs are something like that. So assemblies can be either like DLLs where they are executables but they can't execute on their own. You need to link them with something to execute them. or they can be full executables like exe files. Okay, but basically assembly is a collection of namespaces. All right, now you can have multiple assemblies to build an application. So an application is one or more assemblies. Okay, so this is the hierarchy. So basic unit, they are classes, and a group of classes is a namespace, and a group of related namespaces is an assembly, and a group of assemblies is an application. Okay, so this is how it is sort of structured. Fine. So whatever we learn, it will be minimally a class. So we have to define a class, and inside that objects, not inside that data and functions. Instances of these classes will be objects. Okay? All right. Now, so when you want to use C#, you also have to use a framework called .NET Framework. You wouldn't have used it, right? Yeah. So both are by Microsoft. C# is one particular programming language. .NET is a which basically has two components. One is called CLR and another is called class library. CLR means common language runtime. So what do we mean by this? Anyway, Java, you said you learned. So what is bytecode? Have you heard of bytecode? So what is bytecode?
Machine learning translated language.
Sorry?
Machine translated language. After the code which you have given, it translates to the language which the computer understands.
So that translated language or the translated code is bytecode? So that's like .exe. So you can execute that.
Similar to it.
During the runtime, when we compile it during the runtime, the code that we are getting is converted into byte.
So when we compile, the code is converted to bytecode. That's what he said. So that's what I'm asking. Is it like .exe or a.out?
Similar.
Have you heard of JIT? Just-in-time compilation? What did you learn in any course? You are unable to say anything about structs, you are unable to say anything about classes. But on your grade sheet, you will have object-oriented programming done, C programming done.
We don't have OOPS. For A-Pool, we don't have OOPS in our course. In our subject.
But you have programming workshop in which OOPS is taught, right?
But it's 0 credit.
So you need not learn. See, now each machine has different hardware, different CPU. At CPU level, there are a lot of changes, different hardware. So when you convert your program to machine language, it will look different on different hardwares. Same machine language, you can't take on a different hardware and run. It won't run there. Okay? So if you want to translate your code into a machine language on a different hardware, you need a sort of different compiler, or that compiler should understand on what hardware it is and then convert your code into that particular machine language which is suitable for that particular hardware. Okay, so it means you need to make tweaks in your compiler, like if else conditions. Okay, this is the source code, the program which you wrote. If it is on this hardware, compile it into this language. If it is on this hardware, compile it to this language. If it is on this hardware, like on Windows, you will get a different machine language. On Linux, you will get a different machine language. On all these platforms, you are able to compile C programs, right? But on all these platforms, machine language will not be same. The final binary code will not be same. It will differ. And even within the same operating system, on different hardwares, it will differ. On Intel, it will differ. On AMD, it will differ. On Mac, ARM processor, it will differ. Right? So different processors, it will differ. On 32-bit, it will differ. On 64-bit, it will differ. So many different kinds of hardwares are there. So many different kinds of combinations are there. So you can't write a compiler which is suitable for, I mean, your compiler, individual compiler will become more complex to cover all the different kinds of hardwares. Alright. So one method is convert your code into an intermediate language. Alright, which is portable to any hardware. So once you convert your code to this intermediate language, this code can then be converted to the final binary code. Okay, now you may ask, again for this bytecode we need different compilers or different if else conditions in a compiler. Okay, from this intermediate language, if it is this hardware, you should convert to this binary code. If it is this hardware, you should convert to this binary code, and so on. Yes, sort of, but there are two advantages. One is the process is not as lengthy as starting from the source code. Whatever code you write in a particular programming language, that is the source code. So the process is not as lengthy as that. Second, you need not share your original source code to be implemented on all these different hardwares. You share only the intermediate language code. This is also non-readable. Okay, so like when you install or when you download an exe file, can you read it? No, you can't change the code. You can't read it because it is in binary. Alright, but exe file is like the final binary code. Similarly, the intermediate code also, it is non-readable. So I can share it freely because you can't make any modifications to that. You don't know the source code, right? So privacy is preserved and the process has become less lengthy. So now from this intermediate language, I can convert this intermediate language code to the final machine language code, or that is called native code or binary code. So the original compilation step, which is one step, like in languages like C, that is sort of broken down into two steps. Alright, so you have source code, and then you have IL code. So IL is intermediate language, and finally you have native code or in machine language or binary code. Okay, so this second step in C#, whatever does this, that is called CLR. So that converts the intermediate language code to the final binary code. Alright, and this is called just in time or JIT compilation. This idea is actually borrowed from Java. In Java, this intermediate language code, this is called bytecode. In C Sharp, it is called IL code. In Java, it is called bytecode. So, in Java, also, the source code is first converted to bytecode and then finally converted to machine language. Okay? So, this is called just-in-time compilation. So, you can, instead of sharing the source code, you can share the bytecode. And that bytecode can be compiled based on the hardware. So, C Sharp took different ideas from different programming languages, object-oriented programming from C++ and Java, and security from Java, and some system level functions from C, all these things, and it is built. Okay. So, all right. So, this is the basic understanding of C Sharp. All right. So, before we get into coding, you need to make some settings in VS Code to be able to run C Sharp programs. You all have VS Code? So, let's try to do it now. So, first go to extensions, look for C Sharp dev kit. Okay, why is it not loading? Yeah, I already have it installed. So, you need to install C Sharp dev kit, or you note it down, and then CodeRunner you would have anyway installed already. CodeRunner gives you this button, this run button. It is language independent. It is useful for running C programs or C Sharp or whatever. It compiles and runs. So, C Sharp dev kit. So, let me write. So, C Sharp dev kit, CodeRunner. And when you install C Sharp dev kit, it will ask you to also download and install .NET SDK. This is not available as extension in VS Code. You need to download it online. You need to install these three. Yeah. Yeah. So, once you do that, let me close all this. Okay. So, once you do that, you press Command Shift P, or in Windows it will be slightly different. You need to see command palette. You can go through UI also, view command palette. In Mac it is Command Shift P. In Windows you need to see the shortcut, or directly go through this command palette, and here you should select .NET new project. You guys are still installing? Okay. How much time is it saying? 1 minute. Okay. Done, everyone? So all these 3 you installed, right?
No. C Sharp, .NET, run another code, and .NET. .NET is yet to install other
Online.
online.
Okay, it will ask you probably in the next step. So anyway, those who are able to follow, others ask your friends or ask Manasa or Sai Roshni, they are TAs, they will help you. Yeah, so first, okay, let me start here. In view, press command palette and here select .NET new project. Okay, and in that select console app. Alright, after you select .NET new project, again it will show you a list. From that second list, select console app. Then it will ask you to give a name to that, give some name. Okay, and it will ask you the directory, give some directory. So this will be your default directory where all your codes will be saved. Okay, so I gave a directory, and then in the Explorer you can see your projects you created. So it will create a sort of a project folder in which your code will be there, like console app 5 I just created, right? So in this is a folder in which you will have some other subfolders and files in which our code, this is the main file that we will be working with, program.cs. Okay, so in this program.cs, this is the file that I edited earlier. It was in other, yeah, so I edited in other project, but you can also edit in your own project. So now there are 2 ways of running this file. One is through terminal. Okay, so how do you view the terminal? You already have the view option, so view terminal. Okay, so here you see the terminal open. So in this you need to ensure that you are in your corresponding project file. Alright, so you can check in which directory you are by typing pwd. So right now I am in console app 1. I want to move to console app 5. Okay, so you need to learn some basic terminal commands. cd ... will take you to the parent directory. So now I am in some main folder in which, like you see, this is my main folder in which all these console apps folders are there. So earlier I was in console app 1. So I went to the parent folder. Now I need to go to console app 5. I need to again descend to console app 5. So how do I do that? cd console app 5. Okay, so now check the directory again, it is console app 5. Alright, you have come into the folder. Now all you need to do is type .NET space run. Okay, yeah, done, it ran the code. Alright, another method is just press this button, that also runs the code. Alright, sometimes you will see a debug symbol on this play button. It's not plain play button like this. You will also see like this. You see this? You will see that button looking like this. In that case, don't press that button directly. Click on this arrow and click run code. It will only run. If you click that debug plus play button, it will run and try to debug your code. It will take you to debug mode. We don't need that. We just want to run the code. So if you have a plain play button, you can click that. If you don't have a plain play button, click on the right arrow and click run code. Alright, now you may actually face an error when you try to run the code. It may say script cs command not found. Is anyone facing that? Or still you are yet to install .NET, I think. Okay, again that will take some time. So right now, first at least be able to run through the terminal. Okay, if you try to run through the play button, you will face an error. I will tell you in the next class how to rectify that error, but through the terminal you will be able to run. All right. Okay, so let's stop here.